All right, guys, what is up? Welcome back. This is actually the second page. I lied the first time. I don't know if you guys can read it, but I stole someone's paper because you guys apparently took all my reviews and ripped them up. So I'm now using someone else's paper. You guys should probably, let's see. You guys have done, now if you've done both videos, you've done the first page and the second page. Or in the third page. And now we're actually doing the second page. Oh, wait. Did we? No, I just wrote on the wrong one. Oh, weird. Okay. Anyways. We have actually done the first and third page. I actually like it more in that order, honestly, because we got to fill out this whole sheet in Clarity. So this is something, I'll upload the canvas for you guys. It's a cap of everything. Now, the last thing that I'm going to show today, and I'm going to put it as a small bubble of its own, but this is a complete lie. It is connected to everything. It is involved in every single thing we do. Everything we use can be used in it. It is proofs. Proofs of congruent triangles. Now, proofs of congruent triangles, the most is going to use theorems. Theorems are like statements you can write that are definitely true. They're like the bargain Walmart item for math. Like, you can use it for anything. And it is so highly effective. So, theorems are your go-to for proving stuff in geometry. So, on this second page now, we're going to start the proofs. It should not take us that long. Don't panic. All right? Before we move on, I'd like you to make a correction. Actually, I noticed this mistake in class, but the review has, it's been in, what's it called? It was not in Canvas that long, so I thought that it was just me making the mistake, but actually we ended up being right. So me and I can't remember who I was talking to about this in class, but you guys were absolutely right. This is a definition of perpendicular. Definition of perpendicular is very helpful. Anyways. So, our goal here is to make a proof. It is a sequence. A proof is a sequence of things that you do, and if you do them exactly like they say, you end up with the same result every time. A proof is a way of demonstrating in math that something is true with certainty, with absolute certainty. So our goal is simply to get to here by any means necessary. We want to show that the triangle ABD is congruent to the triangle ACD. So, good thing to do in a proof is to look at the picture and ask yourself if you believe it. Is triangle ABD congruent to ACD? Yeah, I mean, it looks like it, right? It looks like it is, should be, you know? So if we proved it, I wouldn't be surprised it was true, right? I wouldn't be surprised it is true. Oh, maybe I'll write the perpendicular symbol there as well. All right. So, anyways, for this first one, we are given that AD is perpendicular to BC and AB is congruent to AC. So I'm going to draw that in my picture. Here I see AD is perpendicular to BC. That means this line is perpendicular here. So that actually means this other side is perpendicular. So those angle 1 and 2 here are given as 90 degrees. All right. So what I might say is that AD is perpendicular to BC, AB is congruent to AC. This is given. We already knew that. We were starting the problem assuming that. That is what we're trying to show, right? We're trying to show this using this. So this is what we're given. You got to start somewhere, right? And then for the number 2, I would probably say we would like to show that these triangles are right triangles because we're probably going to end up using HL since these guys are right triangles, right? Oh, and also we forgot to mark that these are the same. Since these are right triangles and we have a hypotenuse the same, we're probably going to use HL. That'd be a good hunch. So, by the definition of perpendicular, we could say that this guy and this guy are 90 degrees. So we could say the measure of angle 1 is equal to the measure of angle 2. And there's a bunch of, you don't have to write exactly this. There's a bunch of different possible steps here. If you wrote something else, is equal to 90. I've also seen people write like, you know, these two triangles are right triangles. Okay, I'm fine with that. Like, if you wrote these two are right triangles, I mean, that's basically the same thing. They have a 90-degree angle. I'm in. I love that. So, in any case, since these guys are congruent, oh, yeah, and here we see AD is congruent to itself. When something's congruent to itself, that's this line here in the middle, AD, we call that a reflexive property. We call that the reflexive property. So, REF L-E-X-I-V-E, reflexive property. Very cool. And then finally, if you look at the picture, we see that we have two right triangles, each with corresponding hypotenuse and share this other side. That has to be HL. So the way we prove this guy's possible is using one of those many theorems that prove congruency about triangles. So in this case, we're going to use HL, hypotenuse leg, for that guy. Okay. Beautiful. Now, we know this proof is complete because we filled in every blank, and we can read these sequences of steps that depend on each other. Actually, I would say maybe it's more of a zigzag. But you read these pieces, and by the end, you are certain that what you wrote in the beginning is true. All right. To complete this proof, we're going to draw on our givens just like we did last time. D is the midpoint of CE. So if D is the midpoint of CE, that would mean it's directly in the middle of this. So we'll draw that in a second. Then it says ADE is congruent to BDC. So let's see. ADE here is congruent to BDC. That's this angle. Well, those angles are congruent. So already, you might note these guys share an angle. That's given. Okay? And then we have AE. We want to prove AE is congruent to BC. So we want to show, I'm going to draw this faintly because I'm trying to show that. I want to show this side is the same as that side. I'm not there yet. I got to get there. So D is the midpoint of CE. That was given to us. So in the blank, I write given. We already knew that, bro. It was given to us. So ED is congruent to CD. That would be this line and this line. How do we know those are congruent? Well, we know that D is the midpoint. So since D splits this piece up equally, we could say by the definition of midpoint, it has to be that those segments are congruent. On to the next step, we see ADE is congruent to BDC, and AD is congruent to BD. These were in our givens, if you remember. So in this step, I'll also write given. All right? And then next up, we got triangle ADE is congruent to triangle BDC. So if you look here, we want to show these are the same, and we were given that these sides are the same. So don't look at these just yet. We see we have a side corresponding, angles corresponding, and side corresponding. So it's valid for us to conclude these triangles are congruent using the congruency method of side, angle, side. And that's exactly what we're writing there. Blank, nothing else needs to go there. Now, since these triangles are congruent, that means everything in them has to be the same. So that means the side in question is also the same. To show that, you could probably write something like that. If you wanted to write in this blank, like, all pieces of congruent triangles are congruent. You don't have to put a short, simple, sweet statement in a reason like we usually do. That's just what we do in math because we have good oh, you guys can't even see what I just wrote. You don't have to put something short and sweet in this. You can put whatever you want. If you have a reason you consider to be convoluted, that's fine. Write it out. As long as it's a well-constructed thought that actually supports your statement, I'm okay with it. In this case, we're going to say corresponding parts of congruent triangles are congruent. So yes, we do have, in this case, an acronym, a cool acronym, CPCTC, which tells us that, well, since it's a part of a congruent triangle, it must be the same. Okay, so without further ado, that's the conclusion of these proofs. Make sure you mark it with your like graffiti tag to show you're done with the proof. The test is on Monday. Let's see. If you have any questions, please email me. I'll be looking at my email. I think that should be good. If you guys feel comfortable on the review and you feel comfortable with those, I would say 3 big concepts. The main 3, let's see, maybe I'll get finally some color. Triangle congruence. Congruency theorems use triangle congruence. Proofs use triangle congruence. And then triangle similarity, which uses proportionality, okay, and dilates things. This is the big picture. If you can get this, you should be good to go. So I will see you guys on Monday.